So thank you all so much for joining. My name is Jossi Wolf, and today I'll be talking about our experiences, journey, whatever you want to call it, of converting LiveData to coroutines and Flow. I want to make sure that you all know there's a Slack channel for this, which is the session chat day 1, session 2, track 1 channel. So if you do have any follow-up questions later on, that's the place to ask them. You can also contact me there. I will post some resources and some slides there. So make sure to join that Slack. I'm also on Twitter, and I'll also post a link to the slides there later. So I know, 2020 is just shitty. 2020 just sucks. We just recently passed 4,000 cases per day here in Germany. So I wanted to make sure that we start up this talk with a more pleasant thing, which is my sister's dog, Eula. So I work at Snap Mobile, and we're this kind of agency / consultancy. So we see a lot of different projects. We see a lot of different code bases. And we recently joined a project where the folks were using LiveData like everywhere, like literally every layer you could look, there was LiveData being used. So it looked a little like this. You would have your UI layer communicating with the view model through LiveData, and the repository and the view model would also talk through LiveData. And so if you don't know what LiveData is an observable data holder class. So it's a lifecycle aware implementation of the observer pattern. What does that mean? What does that look like? So say in your view model, you could say, all right, we are creating a new LiveData instance. It's immutable LiveData, so we can change the value. And then later on, you can maybe fetch some data, and that data, you can post it to your LiveData. And in your UI, you can easily just observe that with the view lifecycle owner. So the nice thing about this is that it's tied to the lifecycle, and you don't have to care about unsubscribing when your fragment becomes inactive. And also this resubscribes when the fragment becomes active again, and replays the latest value. So you get a lot of kind of nice things out of the box, and LiveData has been recommended for a long time to be used for communication between view models and UI layer, be it activity, fragments, whatever you might be using. So we learned we really like LiveData. At my company, we really like relying on LiveData, and LiveData is great. I don't want this to be like a rant about LiveData. That's not what it's supposed to be. But there is a caveat to this, which is LiveData is great when used properly. Now, this applies to literally everything, I know. But we had this fun experience so we joined the project, and then after a couple of days, we're like, okay, the code base looks a little messy, just how would it look to everyone when you join a new code base. But then after having played a bit with the app, we were like, oh, wait, why is the app laggy in some places, and why does it just block? Why does it just not respond in some places? So we started looking into this, and we were like, okay, turns out, so something in our code is blocking the main thread. And that led us to a super, let's call it fun lesson about LiveData and execution context. So I want to give you a little look into what our code base looked like. So we would have a repository, say supermarket repository, where we would have a function, for example, fetch opening hours. That would return a LiveData with the data model that we wanted to obtain. This would query an API or query from the database or whatever, right? Just a normal repository. And then we would have a view model, and the view model would have another function which we could call from the UI layer, and then in there we would query the view model, use that other function we had, the LiveData, right? And maybe run some data transformations to make sure we filter out null values because we didn't need it for this exact use case. So looks great, right? That's what we thought. So we were like, okay, is this where our UI thread blocks are coming from? Let's take a look. So we always made sure to call fetch supermarket opening hours in the view model on a background thread. And we were like, okay, this should be running in a background thread as well, right? Turns out, not quite the truth. What was going on was, so first line, right, still being called on the background thread, but the Lambda was being called on the main thread. And we were like, wait, what is going on? This is not supposed to happen. This is not what we want to happen. We never said, hey, we want to switch to the main thread. So we started looking at why exactly is that the case. To understand why, let's take a look at the source code for the map function from the LiveData transformations package. So it looks like this. Essentially what it does is it takes a LiveData, the source, and then it calls the map function on each value that the LiveData emits. So how that works is it creates a mediator LiveData each time. If you don't know mediator LiveData, it's basically a LiveData version that allows to mediate between one or more LiveData sources. So you can get emissions from LiveDatas with different types and transform them to be one type. So first, creating the mediator LiveData instance, and then second, calling add source with the LiveData that we wanted to transform. And after that, the Lambda would be called. So what's happening inside the Lambda is first, the map function gets called with the newest emission, which is X. And the return value from that map function gets set as the current value of that mediator LiveData. And finally, this mediator LiveData is cast to just normal LiveData and returned. So this looks kind of great still, right? We were like, okay, where's the obvious thing that we're missing? So what we did after like a couple of hours or days probably after investigating was, you know, like any developer, read the documentation. So in the documentation, it stated that the events are dispatched on the main thread. So that means that every LiveData observer is always called on the main thread. And if you keep the code in mind that we just had, we would have an observer with a mediator LiveData, and the map function would be called on the main thread every time. Not exactly great because it's super, super hidden. So what we learned was LiveData is really nice. It brings a lot of nice stuff, but it's just so easy to let things slide when you're using LiveData, and you really got to watch out for things. And this is stuff that a linter probably cannot save you from even. So we had this kind of big project, and we're like, okay, what are we gonna do? We have a lot of UI thread blocks. We have a lot of places where things are just going wrong. So we had two options that we found ourselves with. First option, replace LiveData, just, you know, get rid of it entirely, because why not spend a bunch of time on that? And second, make sure threading is done properly. Both of these options equally suck. We were not happy with the options that we were presented with, but we had to choose. And we ultimately went for replacing LiveData with something else, because we were like, okay, making sure threading is done properly, this is a hard task. This was a huge code base that we did not own, that we did not know inside out. So we couldn't be like, oh, we can do this here and here. But this would have been a lot of work. So we decided to replace LiveData with something else that would give us more control over execution context. So what we did was we looked at our things that we had going on. We discovered that we generally could divide up all the use cases that we were using LiveData for into two categories. First of which was one-shot events. So that's really just anything that just returns a single value, where in RxJava you might have used a single or maybe, and here was just a LiveData. And we were like, okay, really, it just does not make sense to have a full-blown observer pattern applied for just that. So we went for coroutines. Coroutines are recommended by the Android Developers Guide, and if you're here, you probably know coroutines. If you don't know them, try them. We had used them in previous projects before, and we thought it was just the ideal solution because it offers a lot of flexibility over execution context, and it's very easy to always make sure that you're running on the right thread, which was exactly what we needed. For streams of data, since we already went with coroutines, we decided to go with Flow. Flow is Kotlin's, the coroutines, Flow is the coroutine library's solution for reactive streams. And we figured that it would give us similar benefits to everything that coroutines had to offer out of the box. So let's talk about converting to coroutines and how we actually migrated our things. So I want to give you a quick look into some more real code that we had. I don't need you to understand all of this or read all of this. I just want to make the point of this is what it looked like with LiveData, and we were also using callbacks with retrofit responses, for example, which was just contributing to a lot of load and contributing to having a lot of boilerplate. So the first thing we did was switch to retrofit coroutine support. Retrofit has coroutine support built in since a couple of versions. It works super well. It's first party. You can just go make this a suspend fun, and it works out of the box. That's what we did first. And for that, we had to make our fetch opening hours function suspend, which it was not previously, but that was fine for us. At this point, it was still returning a LiveData, but this was like our kind of first step to get rid of the bloat. So if you look at the code that's going on in here, you can see that the actual thing that is happening is only delegating to our POI service. The other 3 lines that are going on are all about the LiveData. So it was easy for us to figure this just we should not create a LiveData here every time, because that's a lot of code just to do that. And why would we? So we would just have a pure function and make it suspend, take away all the LiveData stuff from the repository layer. Now that's a nice thing to say, like, hey, we just did this, but you probably will need some migration strategy in the real world if you are living in some kind of interconnected code base. If you're living in a code base with legacy code, it'll not be as easy as just saying, oh yeah, we switched to coroutines, done. So what we did was we introduced migration helpers, and we leveraged some awesome Kotlin features. So the first thing we did, obviously, was keep our pure function, fetch opening hours. That's just a coroutine. And then we would introduce this migration helper called fetch opening hours as LiveData. And we would go like this for every function. We would just append as LiveData to make it clear, hey, this is a LiveData thing. And then we use the LiveData builder. Finally, we'll get to the LiveData builder in a second. Finally, we annotated this migration helper function with the @deprecated annotation to make it super clear, hey, if you're working on this, you should not be using this anymore. The @deprecated annotation allows you to specify a message and a reason for why you shouldn't be using this anymore. And you can also specify a replace with, which is an expression which will enable auto fixes along the whole code base, which is very nice. So this was nice, right? But we still had a problem, because what about the execution context, you know, that we actually cared about? So it turns out this whole Lambda was still being called on the main thread, which is bad, which is not what we wanted. So it turns out with the LiveData builder, you can actually specify the execution context, which is very, very nice. You can specify a dispatcher. So that's what we did for all of our migration helpers. And then we had our repositories. Now, you know, it's suffice to say, this is a lot of work, this is a lot of tedious work, but it's kind of like the smoothest path that you can go to make things work without having your main thread blocked. So, second step, after the repository, we wanted to migrate our view models, obviously. So now that we were still using the old function name, right, first action is to switch to the new migration helper, and things were still working. The nice thing is when you annotate a method as a deprecated, your IDE will show you, all right, this is, you know, like it'll be in strike through, so it'll be super clear that you should not be using this anymore. But we were obviously still having the issue with the transformations being called on the main thread, right? Due to what we discussed earlier with mediator LiveData and how this works under the hood. So we were like, okay, why do we even have this migration helper in the repository? Why not switch it out directly? So we went to our view model and we basically copy and paste the code from the migration helper from the repository into the view model. And it would look like this. So now we didn't have an annoying map call anymore. We had full control over the execution context, and our repository was pretty cleaned up. So that's super nice. This is a strategy that worked super, super well for us. Our code base was not super small. It wasn't super huge, but definitely a considerable size. And if you're working on a normal app, this is probably a very good strategy for you if you have legacy code like this, especially if you're looking to go from LiveData to Coroutines and Flow. All right. So the other thing that we had was converting to Flow, obviously, right? This was only for our one-shot values, and now we one-shot events, and now we wanted to convert our, you know, the actual streams of data. So we used to have code that looked like this. Again, if you kind of look at, you know, the real function, you'll see that there's like, let me count, 1, 2, 3. There's like 3 lines of just code responsible for the LiveData. Well, 2 plus the return, but you know, 3. And then there's 3 lines of actual code, which is like, that's just so useless, right? Same thing as before. So first thing we did was change the return type of the function to a flow. And then we could leverage the flow builder. So this is super similar to the LiveData builder function that we saw before. It has basically the same API. It works very, very nicely. It does not let you specify the execution context, but that's not needed. And then we would have all our code. We would fetch the data from the cache. We would look if something's in there, and if yes, emit that. And then we would download fresh data and emit that. This is a super nice, easy migration, especially if you're already using the LiveData builder. If not, it's a bit harder, but still a migration that's okay to do. So we also went for having migration helpers for migrating to Flow, because we couldn't migrate all of our view models immediately, especially for things that were at the repository layers and being used by multiple screens in all over the code base. So what we did was we also created helper functions, fetch supermarket details as LiveData, annotated them as a deprecated as well. And then there's this super nice extension for flows, which is as LiveData. And it just converts a flow to a LiveData using some nice things under the hood. It's not tied to a life cycle or anything. And that's a very nice helper and way to migrate or way to interoperate between Flow and LiveData. Similar to the LiveData Lambda builder, you can also specify the execution context of the flow. For this, we also went with dispatchers.io, right? Because we wanted to make sure everything that we had was running in a background thread. Finally, this is what a deprecated annotation looks like, where you can just say, hey, please use flows directly or something. Yep. So, wow, I am extremely fast today, which is nice for y'all. So you'll have a longer break. But the kind of last thing that I wanted to touch on is StateFlow. Well, I was planning on doing like a hands up, but turns out I don't think I can see you raising your hands. So StateFlow is a new subtype of flow, and the pull request, it's really new. I think it's been merged like a couple of coroutines versions ago, and I don't think a lot of folks out there are actually using it yet. Also because there's still some stuff missing. So this is very experimental and cutting edge. Those things might change. Those APIs are experimental. So a StateFlow is a flow that represents a read-only state with a single updatable data value that emits updates to the value to its collectors, which is, I'm not happy with that wording, but basically it's like LiveData. It's really similar. It's basically a flow that emits a value that's used for representing state, and it always replaces the latest value when you subscribe to it / when you collect it. So I want to mention how migrating to StateFlow from LiveData works, because we only talked about, we only looked at migrating repositories and the communication between view models and repositories so far, but there's still a whole bit between the view models and UI layers. So we actually think that using LiveData between the view models, between view model and UI layer is totally fine. It works very well. It's nice as lifecycle aware, but still I want to shed some light on this since it's being mentioned by some official guides more and more. So say this was a review model, and we would return a LiveData, which we would then subscribe to as we saw earlier. The first step towards migrating to StateFlow is changing the return type to unit. Instead, this is a method that you can use for LiveData as well, right? So we would launch a coroutine on our background thread, right? Super important. I know I'm making that point a lot, but I saw so many mistakes with this. And then we would, fetch our data from the repository, do whatever, and then set the value of the opening our state property. So let's look at the opening our state property. Now there's two things that we have going on here. Now there's underscore opening our state, which is a mutable state flow with an initial value of an opening of an empty state. And then there's not underscore opening our state. That's because StateFlow is the non-mutable version. So you can't mutate the value of StateFlow. For that, you need mutable StateFlow, and the only way to create an instance right now, unless you're implementing the whole StateFlow interface, is to create a new instance through the mutable StateFlow function or constructor. And then we want to make sure, I actually got this wrong, fun. You want to make sure that underscore opening our state would be private because you don't want any outside accessors to be able to mutate your state. That would be quite bad. And then we expose our actual state flow, the non-mutable state flow, just like that. And we would be able to use it in our UI layer like this. You could say on each render opening hours, call that function with the latest value, and launch in lifecycle scope would be kind of the equivalent to calling observe on LiveData with the lifecycle owner. So the lifecycle scope, if you don't know it, is provided by the Kotlin extensions, lifecycle Kotlin extensions package. It's basically a coroutine scope, which is bound to the component's lifecycle. So with this, you also don't have to worry about your fragment being destroyed or becoming inactive. And you also get the same benefits that you have with LiveData out of the box. So why would you actually do this other than, being a cool kid and using the latest stuff? I'm sure there's a lot of reasons. I'm just going to go for 3 of them that I think are important. First thing is single API instead of 2 APIs. You only need to care about the Flow API now, which is getting more and more popular, and you're seeing more and more all over the place. So it does make sense to learn a lot about it. You don't have to care about Flow and LiveData side by side anymore, which is super nice. So it's just one thing less you have to learn. Execution context. All methods of the StateFlow are thread safe and can be safely invoked from concurrent coroutines without external synchronization. This is something that's super annoying with LiveData. That's due to LiveData's design. And this expands the things that you can use StateFlow for. This is not something that you could easily do with LiveData. And you just have a lot more control over the execution context / the control gets a lot easier and you have to worry less about things. Lastly, it does integrate very nicely with Jetpack Compose. If you have played with that already, you might know there's the extension function on a flow, which is called collect a state. And then if you use the value from, it returns a state flow. And if you use that value from the state flow, it automatically triggers recomposition. And that's a very nice integration. Go check that out and go take a look for that. So that's why we're using StateFlow might really make sense. It's still super experimental and things are still unclear. Not a lot of people out there are using this, I think. StateFlow is there in the Kotlin coroutines package, and you can use it, but some operators are missing. They have been merged, but they have not been released. So you might want to hold back on using this in production just for a bit until some more resources become available. Speaking of resources, I do have a couple of links which I'll be posting in the Slack channel, and I'll be posting the links to the slides in the Slack channel and on Twitter as well. Obviously, the Android developers' documentation on LiveData is actually quite good. So it does make sense to read that if you're looking to go away from LiveData or just looking to learn more about LiveData. I did write a post about our reasons for not wanting to use LiveData in repositories. And there's a very good post by Roman Elizarov, I hope I pronounced the name right, about the execution context of Kotlin flows and how that works. I didn't want to touch on that topic too directly right now in this talk, but that's a very good overview. It's a lot simpler. And finally, there's the, well, for now, kind of bare bones-ish documentation on StateFlow. That's the link to that. But definitely go check that out, play with it, see if that makes sense for you. And yeah, thanks so much for joining. It's 2020, so here's another dog pic. Well, actually, I put dog pics in all my talk, but still. Thanks so much for listening.
Awesome, fantastic. Thank you, Jossi. So I guess at this time, if anyone has questions, you know, you could drop them in the Slack channel or in Zoom here in the Zoom chat, and I'll read them off to you. I'll drop the Slack link in case nobody has it there. Yeah.
We can also take questions here in Zoom if that works for you, whatever is best.
I think I saw one question, but I think you might have addressed it before. This comes from Robert, and I think it was about the opening hours state that's supposed to be private.
Yes, it's supposed to be private. I just noticed while talking, this is what you get for doing slides last minute. Sorry, it's supposed to be private.
Okay, so here's one from Angelina. Have you written unit tests for your flow and view model? And have you noticed any issues?
So actually, we have written unit tests for the flows, and it's been a lot easier. We're using Turbine, which is a kind of newish library by Square. Go check that out. It's very nice. And for us, it's been a lot easier to unit test things. Would definitely recommend it.
I got another question from Thomas. Once StateFlow gets to a released state, do you see any reason to continue to use LiveData?
I don't see any reason to go drop everything and migrate away from LiveData, but if you're starting a new code base and you're using Flow anyways, it definitely makes sense to use StateFlow. If you're not using Flow or coroutines in your code base, it's totally fine to use LiveData. I don't think there's like a super clear opinion by the Android advocate or by the Android team on whether LiveData will continue to be the recommended solution. But once StateFlow has been stable, or once StateFlow is stable, I think it's definitely fine to go for either of them, but don't go drop everything and migrate to it just for the sake of being a cool kid.
I got another question here. How experimental are we talking about for flows? I find it hard to convince people at work to use it right now due to its status. What is the best choice to use now that will enable easy refactoring into flow when it's out of experimental state?
So I think it's worth noting there is, not all flow APIs are experimental. As far as I know, I hope I'm not getting this right. Scream if I'm not getting this right. I think there's some flow APIs which are experimental and some are not. I know people are very hesitant towards flow. I am too. And I think the best advice that I can give for this kind of stuff is the same with RX. Just keep the usage to a minimum if you don't have like a real good reason to go full blown for it. I wouldn't recommend going for LiveData or RX anymore for anything that's outside of view model UI layer communication. I would just recommend trying Coroutines and Flow for this. Give it a shot, and let people actually try it and show them some of the benefits, which are testability with Turbine, easy control over execution context, and very, very nice readability, and a lot of nice operators that are easier to understand than, for example, RX. And you don't have to roll out your own stuff as with other observer patterns. I think showing people those benefits will probably give you a good chance of convincing them. And that's, using that is probably the best choice for now.
And two more questions. So we are using data binding, XML plus LiveData. How can Flow work in this case?
We're not using data binding, and I haven't used it in a couple of years, so I'm not sure I can give you an answer, but I think there are some guides which are supposed to come out soonish. Keep an eye out for what the Android advocacy team is saying.
All right, and so do you find any specific time or reasons to use LiveData over coroutines and coroutines over LiveData?
I think for anything that, so for anything that's between view model and UI layer, I really want every state that the view model exposes, I want it to be exposed as StateFlow or as LiveData, because that makes sure it replays the latest value when the subscriber/observer becomes active again. So that makes sure that the value is restored after the fragment becomes inactive, gets paused or whatever. And then using LiveData over, using coroutines over LiveData just for anything that is not lifecycle related, I would really not use LiveData.
All right. So I don't see any more questions coming in, and we're almost at time. So yeah, I think that's it.
Thanks so much for joining. If there are any questions, feel free to ping me on Slack or on Twitter. Let me know if anything's up. Thanks so much for listening.